What's up, everybody? I'm Tucker, and this is Tuck Talking Tech. And today we are talking about AI-proof skills for your software engineering career. So because of AI coding capabilities, there's a lot of angst and concern over where the software engineering field is going. What is going to happen to our careers? Is AI going to replace all of us? Is everything going to be an agent? The gist of today is that we as software engineers are more than just the code we write. The skill set required to take a user request or a business requirement and convert that into software that scales and software that really works in production is a non-trivial task. And it's a skill set that requires more than just writing code and deploying some application. The hard skills are extremely important, and some of the hard skills are what we're going to talk about today, but we're more than just those skills to write code. And as AI becomes better at writing code and we write less code, it's going to compress the amount of time that we normally spend on writing code, and therefore it's going to expose time for other skills and other parts of our workflow to be amplified. And so if those parts of what we do are amplified, then we need to make sure that our skill sets are also amplifying those specific things so that we maintain a level of value and we maintain that we are a high level contributor for our organization, whether that's through the code we write or by whatever means it takes to deploy software or whatever our role evolves into. And I can't predict where AI is going to be in a year. I can't predict where it's going to be in 6 months. We might be at the peak or we might just be at the beginning. But I'm going to argue heavily today, and I'm going to promote a set of skills that are more than the code, and that it's going to make you more valuable than just your code. And it's going to help you think about your career as a software engineer in totality and really think about what it takes end to end and the abilities that you are crafting each and every day. So the first one I want to talk about is learning agility. And so what is learning agility? To me, it's the ability to take in some new skill or step into some new requirement and be able to learn the underlying, say in technology, the stack or whatever it is, the thing you need in order to solve some task in what I'll say short amount of time. And so think about someone with high learning agility in the software context. It's that guy that always picks up that new tech stack like that. Or he just picks up new languages really fast. Or he can just understand things that it's new, it's some new technology, it's some new way of thinking about applications, and it's something that comes relatively easy. And maybe I said he, say it could be guy or girl. And so I would identify that as someone who has high learning agility. Typically in the software engineering career, you develop high learning agility because technology is ever evolving. There are very few applications today that are running on the same stack they were 10 years ago. And there's very little today in technology that was the same as even 5 years ago. Think about with AI, perfect example. We are constantly in today's age evolving to what AI can do, the new capabilities, making sure that we are taking advantage of all the technologies out there. And that requires new skills. Take that back to when you first started learning programming, and maybe you're in this phase now where you're just now learning to write code and it's really hard and you're struggling, but then you're just picking up skills little by little. You're understanding OOP, and then you're understanding data structures and algorithms, and then you're learning how to actually put data structures into practice. You're building this skill of learning and applying that to something real, which is really what software engineering is really all about. Is you are constantly taking in you're evolving something you built to do something it hasn't done before, and that often requires us stepping outside of our comfort zone and applying a new skill or a new ability. And to do so is a skill in and of itself. Learning is a skill. Being a good, or the good's a bad word, being a proficient learner is a skill. Having high learning agility is a skill. It takes a desire to learn, one, and then two, it takes the ability to actually take in that information, know what to do with it, and apply it to something tangible. And not everyone has this desire. There's a lot of people out there, and it's perfectly acceptable to say, I write CRUD apps and I like it. My job is simple and pays the bills, and maybe you're not a software engineer, like whatever it is in your career, like you have this thing and you do it over and over again, and that's just what you do. Totally fine if that's where you're at. We all work and pursue passions for different reasons, or our passions lie in different places. But in the realm of software engineering, if you can take that passion to learning and take pride in it as a skill, a first-class citizen in your software engineering arsenal, then it is something that compounds itself. You learn things faster and faster, you pick up on things, and then you also start to build the intuition of things that you need to learn. If you're always focused on what's the next thing I need to be learning to make myself useful, I believe you will naturally adapt to where we go in this world of AI. You're going to see what the trends are, and rather than resist them, you will embrace them, and then you will be able to apply them in short order. And so having that learning agility is a mindset. And when you apply that mindset each and every day, it tends to take care of itself in terms of making sure you're working on the right things. And so if you're in the beginning of your career and you're worried about where software engineering is going, don't worry too much about that. Pick up the skills required, because that in and of itself is going to force you to really learn something challenging. And most people don't really push themselves to do that. So step one, push yourself to learn this challenging thing that is programming, and then apply the skills that are enabling you to learn the learning mindset to your work each and every day to make sure that you are up to date with the current trends. Understand that your skills are what the market wants. Market still wants and needs software engineers, still needs programming. So don't worry too much about where the future is heading, because if you are focused on the learning side of it, as the future becomes the present, you will be able to take in that information, understand what are the things you need to pick up, what are the skills you are less proficient in that are now becoming valuable, add those to your toolkit, and then you apply those, and you continue to be valuable to yourself, and you continue to be valuable to those in the marketplace looking for said skills. So prioritize learning agility, prioritize learning as a skill. The next thing is the ability to think in the abstract and decompose that into something tangible and actionable. Or said in a more software mindset, be able to take in high-level requirements and convert that into something you could actually write code against. I'm calling that out as a specific skill because the ability to take a high-level idea and write that into functional code, that's like the core of what we do. Whether that's you're a junior pulling down just Jira stories with simple tasks, or you are the chief application architect of some area of your company, and you have to be able to take this high-level request and then map out all the services required, and then say this is all, this is how we're going to write the code. Like all those things, filling in all those pieces. That is a skill, and it's a unique skill to those, I find at least, who work in some form of an engineering context, even not just like software engineers. And this isn't engineering, but I went to school for mathematics in college, pure math. And so you're writing a lot of proofs. And the one thing I think about and draw on a lot is my experience in real analysis, where you are proving a lot of theorems that have to do with numbers on the number line, and then a lot of the concepts in like Calc 1. So like limit theorem, derivatives, integrals, things like that. So like the kind of simple things, but it was my first experience dealing in the abstract. And so what that means to me is, when I think of abstract, it's things you can't like tangibly grasp. So one of the theorems, axiom of completeness, you're proving like why real numbers exist. And how do you do that like tangibly? Do you go write every single real number? Well, we know that's impossible. You cannot write every single real number, because if you try to wedge another number between two real numbers, you just get another number. So you just can keep doing that forever. So you have to be able to decompose that, break that down into theorems that you can grasp. Okay, what do I know about this? Where can I work from? And then you build up into something until you have logical proof. So now take that kind of mathy concept and think about how we write software. It's really the same exercise. We're taking this complex thing and we're breaking it down into things, into knowns that we can action against. So if you are a lead engineer, you're taking down, or you're taking that request and then you're breaking that down into maybe the tasks that need to have, like the actual bits of code that need to write. Or maybe you're just looking at a very specific, narrow feature and you're saying, okay, there's this feature request, here's what the code doesn't do, here's what it does do, here's what they want it to do now. And then you're finding a way to make that actionable. That is a very strong skill. And maybe it ends up being that when we do this exercise of high level to low level, the low level maybe isn't writing as much code. Like say you spend 60% of your time writing code and it turns out that AI compresses that and you start writing 30% of your time code and it keeps dwindling. Well, I think I'll argue that there's still going to be a lot of time into thinking about like, well, how do we actually take a user request and convert that into something actionable? One of the funny jokes I've seen is like AI will automate software engineers out of their jobs when people know what to ask for, or like the incompleteness. And I definitely can relate to that. Like, I don't know that I've ever gotten to like a fully like feature complete request. It's probably not the right way to say it, but a like fully complete request, whether it be for like a new feature or building some application that didn't require some back and forth with the business. And so because of that, there's gonna be this premium on understanding business requirement and then understanding implementation requirements. And it's like if product's over here and engineering's over here, then I think what I'm saying is that there's gonna be kind of this middle ground where if you can understand both sides, then you're still gonna provide a lot of value. And that's not even specific to like the future of AI and what AI can do now. Like that's true now. Like the best engineers are people who understand the what and the why, and then also really, really understand the how, and can move along various places on the spectrum of, okay, thinking about the product and the why, understanding your users, and then thinking about the how, and being able to go back and forth between the two. That's always been valuable. And I think I'll argue that it's going to continue to be even more and more valuable if coding does indeed to become more commoditized than it even is today. The next thing, and I don't know that this is specifically a skill, this is a little bit broad, but it's the idea that it is to make yourself more than a coder. So I think I'm going to piggyback off the second thing I mentioned, which was being able to convert high-level requirements to actionable pieces or actionable components, whatever you want to call them. And when we talk about being a software engineer that's more than just a coder, it's very in line with that idea in that it takes a lot to write software. You need to be able to understand trade-offs. You need to be able to understand the business. You need to be able to communicate. And there's just so many things that it takes to be able to get to the point where you have a deployable unit of software. And so as you are evaluating your skills as a whole, index on the things that aren't just the code. The system level thinking is so important. Understanding architectural trade-offs, understanding how to lay out implementations that make it easy for AI to operate on. And sometimes that's like testing. Being able to have a really quality and reliable test harness is a really big asset to AI. And which, like, to go on a brief tangent for a moment, it is interesting to think about, like, where is AI really going to be taking over all the engineering tasks we do today? Like, think about legacy software where the code base is just an absolute monster and there's no tests, there's no coherent flow. It's like maybe a decade of different developers coming in and out, putting their own opinions on like a portion of the code, but it still somehow runs. Nobody knows how, and you just kind of avoid it unless you have to. Is AI really going to excel in fixing those codes, like those code bases? No, like I wouldn't let AI touch that with it, ever. Like that's how you end up with like major issues. But if you did have testing, Well, then you could argue, okay, like go put a test harness in place, and maybe it's like I want AI to help me refactor this whole thing. There's been some real big wins out there for people using AI to refactor, but it's always prefaced with, we have this like money test set or test harness. The reality is most software out there does not have that kind of test harness. So it does pose the question, where will AI take those things over? I don't know. Maybe you can tell me and you have an opinion on that. And there's a way I'm not thinking about it, but I see that as one of the challenges for AI really taking over software engineering. And there's a whole like myriad of things that it's like, other than just like writing a simple API and doing certain things, that I don't know that AI is going to jump on that right away. And I'm not here to advocate for like software engineers versus AI and all this stuff. It's just like, these are just thoughts as we're seeing the claims come in about what AI can do. There's still a lot of things out there I think the public probably doesn't realize has to happen before software engineers really go away. So it further doubles down on like why we're here about, okay, prioritize these things about your career and your skills so that you are usable. And it just so happens coding is still a very valuable skill, but be more than the coding, because you want to make your career as flexible as possible and you want to be as useful as possible. So the last thing I want to get into is communication and emotional intelligence. And so communication can mean a lot of things. One of the things that comes to mind is the ability to articulate technical things, technical concepts in a non-technical setting is one of the most valuable skills you can have. At least in current state and for some time in the future, there's gonna need to be someone who knows what does software actually do? What does it mean? We have these user requests, and like, how does this actually get turned into code? And when it is in code, like what are the problems we're facing? What are the constraints? Being able to communicate that to a non-technical person, that is a skill, because it implies you know your stuff, like you understand technology and software, and you know your audience. I think about earlier in my career, and I kind of cringe, where I took so much pride in the tech, like knowing the technical and like understanding certain ML concepts, or understanding some optimization we did to make something run faster, and like, I'm so smart, cool, I'm gonna tell everyone about it. And you're in a meeting or a stand up, and you're talking about this optimization, and you can just see the business people's like eyes like glaze over, and they're like, what is going on? And I look back and I'm like, oh man, it's just like, it's not the way to go about it, because no one really cares how you did it. From a business perspective, most often there's not as much care about how you did it. They just care that you did it and it does the thing they want. Now, when you're with your engineering team and you're nerding out, like, yeah, that's the time where you really appreciate that, and it matters. Like, these things absolutely matter. But know your audience. So the ability to communicate according to your audience will take you very far in your career, whether that is talking about technology or not. Knowing that you're talking to a junior, like, don't just show off and say all the fancy things you know and all the concepts and to impress, and then all of a sudden, he can't do his task or she can't do their task because you gave them a bunch of jargon that they don't really get. Or similarly, back to the business example, you're talking about implementation or some architectural decision. You want to be able to communicate that in a way that they understand, because you want and need them to buy in. And so the ability to take this complex thing and convert that into something anyone can understand, people will appreciate you more, and it also will help to, it will give you more influence in your organization, because there'll be more people who understand what it is you're doing and why. So you'll get more buy-in, and you'll get more support, and you'll get more appreciation for what it is you do, because non-technical people know, like they know we're dealing with things like they don't get. And they definitely appreciate when you can sit down with them and explain it in a way that makes sense to them. So it shows an awareness about who's my audience, and it shows a proficiency and taking something that's really challenging or say really, really complex or abstract to someone else and convert it to their speak. Now it's also like it's bi-directional communication. Like you want to be able to go from the non-technical and talk technical, and you also want to go from the technical to the non-technical. So it's both the skill that imply you know what you're doing and you know your audience. So that'll really pay dividends if you can build that communication skill. And whether it's about software implementations or not, it's just this idea that you're aware of your audience and you're very fluid in how you articulate. And so prioritize that as a skill, and it will make you, like, being a valuable communicator is worthwhile no matter what you're doing, like relationships in your personal life, business, technology within business is really is never undervalued, I would argue. And then the other thing is emotional intelligence. Emotional intelligence comes up in a lot of ways, in a lot of places in technology. One of the things I see often is getting clouded. You're letting your judgment be clouded by your emotional attachment to some work you've done. And why does that matter? Because when we get emotionally attached, we tend to make poor decisions. So to make this concrete, imagine that you implemented some feature or you came up with some architectural pitch and you're really like, you love it, you think it's it. And then someone comes along and they just step on it, whether it's a business user or an engineering person, and they're just like, this isn't good, this isn't right. If you're emotionally attached, you are not going to respond to a way that's going to be conducive to moving that conversation forward. And you're going to block yourself from understanding another perspective that might enhance your own thinking, or someone's thinking about it from a lens that you just didn't, and maybe it's a miss on your part, or it's just like it's another perspective. And maybe you ultimately decide like, I don't think that's right. And so I hear you, and you can reason about, hey, here's why I actually think that may not be a big enough deal to like really worry about. Or you're saying, I hear you and you're right. And so we are like, yeah, we need to pivot. We need to make this change. And you can be a part of that collaborative effort to make this change. And so this implies that you're being very cerebral about your work. And you're being understanding of other perspectives, and you have an awareness that you don't know everything and that other people have perspectives that may or may not be valuable. Because the one thing you don't want to do is like get caught for like 5 days just like on the thinking stone because you're getting so many perspectives and you're like, I got to listen to everyone. I got to know. What if someone else knows something I don't? Like, yeah, okay, that's always going to be a reality. At some point, like, you got to be able to make a decision, be confident, go forward, do it, make it happen. So don't get stuck in this thinking game. Gather the information you need, make informed decisions, involve the right people when you make your decisions. And I think that's probably a skill too. Like when you are making a decision, bring in the people that you know that either know more than you or they're trusted advisors. And do it from people with other stakeholders. Get someone from the business, get someone from the engineering organization, maybe get, keep going down the list of people that might provide value into what the problem is you're solving. Get your information, make informed decisions, but you can only do so if you maintain this level of emotional stability in that you're not becoming attached to the work you're doing. And so in this example, and in our context as software engineers, our emotional attachment that we have to be aware of is to the code. But beyond a software engineer, that's just a skill and ability you want for all the decisions you make in your career. And so if tomorrow it's not writing code because AI is writing more code, well, that's still a skill you want and need and have to have in order to make informed cerebral decisions. Because the worst thing you can do is get emotionally attached, frustrated, or like go off on someone and lose it, or just bulldoze ahead, do the wrong thing, get so far down the road, and then you had people telling you, told you so. That is not where you want to be. So it's a risk mitigation. It's also like people are just gonna wanna work with you more. If you're collaborative and you're just a cerebral individual and you're just really being thoughtful about the work you're doing, people like that, people love that. I know for myself, the people I strive to be like in technology and just, life in general, but as it pertains to technology, are those who are just so thoughtful and willing to hear others out about their opinions, and then can also articulate why they don't agree with that opinion, and then can win people over like, okay, that does make sense. Which again implies like a high degree of competence. So, the hard skills matter. And so do these soft skills, and there's a really nice synergy between the two. And the people who are the best at what they do in technology are the people who can bridge that gap, who understand both sides of the coin and can communicate effectively, remain detached emotionally from the work they're doing, and make informed choices. So to wrap things up, if you take nothing else from this, it's that in your quest to become a world-class software engineer, you will inevitably become more than just the code you write. So recognize those skills which are contributing you to becoming a better programmer in the software implementation side of things. Recognize those. Make sure you continue to index on those as the market adjusts and asks for certain things. But don't get caught so worried about where is it going to be in a year, where is it going to be in 3 years. If you have these abilities and you have these skills, if you have learning agility, you have the ability to take high-level concepts and take them into actionable things. If you are more than just a coder, and you're a great communicator with strong EQ, you will have the ability to adapt to whatever this AI-forward world will become. Because who really knows? So let's not waste our time trying to figure out where it's going to go too much, and just make sure that we're making informed decisions and that our skill sets are reflecting what the market wants. And it's these principles that are going to help us be in alignment with where the world is heading and how we can be most valuable to ourselves. So with that said, make sure to go out, keep building, keep taking pride in the end-to-end requirements of being a software engineer. So with that said, peace.